In this lesson, we'll go over how to create basic assembly motion. After completing this lesson, you'll be able to use as-built joint, use joint, and create a rigid group. To get started talking about assembly motion in joints, open up the FatShark 700 TVL camera file provided with the course. This file is a basic representation of the 700 TVL camera purchased from one of many online retailers. In this version of this camera, we have a very nice integrated package created by FatShark where they've created a molded camera housing that integrates both a tilt and pan servo. Now in our case, we only need tilt, so we're actually deconstructing this, removing the green servo as well as some associated injection molded plastic pieces, and we're only using the tilt servo. Now a portion of the tilt servo is actually held with part of the bracket that holds both of these together. So we have to create our own version of that integrated into the 3D print. More on that in another lesson, but for right now we want to focus on how we can get motion between components. Right now everything is free to move about in this assembly environment. We're going to revert back to this position, and we want to talk about how we can create both as-built and manually built joints. To get started, let's hide the tilt mount and let's hide the camera, just showing the tilt servo and the pan servo. The first thing that I want to do is I want to fix the pan servo in 3D because right now it's free to move around. So we're going to right click on it and we're going to select ground. Now if we grab it and try to move it, it's no longer able to move. If we grab this one here, you can see it's still free to move, and we're going to go ahead and revert its position. As we rotate it around and we expand the tilt servo, notice that we have tilt servo with two bodies in it. There's a cable guide body and there's a tilt servo. The cable guide body is actually the portion of the injection molded plastic that holds the two together and allows the cable coming from the camera to wrap around and go back out so that it doesn't get bound up when things tilt or pan. We don't really need it in this file, but the only reason I left it in there is so that we could see that there's no round section between these two servos where we can actually go back in and make a joint location. So this is important because the as-built joint is going to allow us to make use of their current location without having to worry about specifics like that. When we talk about assembly motion, we need to make sure that we understand that components can have joints, but bodies cannot. Now currently we have a pan component, a tilt component, a camera, and a tilt mount. Each of these are components and they can be activated and worked on individually, and this means that we can apply joints between them. If we simply just have a body at the top level, that is going to always be fixed in the environment, with the exception of using modify, move, copy. It cannot have assembly motion associated with it. Let's go to our assemble dropdown and select as-built joint. We're going to select our components, and by default it's set to rigid, but we're going to use revolute, and then we need to select the position. Now we're not looking for a position that will define their location in relation to each other, but really we're looking for the pivot location. So we'll select this, and the preview on the screen takes the selection of the green servo and rotates it, but that's okay because this one is ground and now the red one can move around. So this is great because we don't have a location on that servo that can actually dictate where that motion is supposed to be, but the as-built joint already took care of it for us. We're going to revert the position, and now we want to show another component. If we bring in the camera and we bring in the tilt mount, we want to take a look at two things. The tilt mount is going to bolt to the servo, and the camera is going to be partially aligned to the servo and partially aligned to the tilt mount. So in this case, we can actually omit the tilt mount, and we can just take a look at applying a relation or a joint between the camera and this portion of the servo. Now they're not currently next to each other. If I revert, you can see that it looks like it's in line with it, but we're going to move it away and we're going to capture its position there so that we can take a good look at how we can apply joints if things are not designed inside of Fusion. So from the assemble dropdown, we'll select joint, and the big difference here is when we select components, we need to be aware of the location we're selecting as well. When you use an as-built joint, you only need to focus on selecting the components, and then you can go back and pick the position. In this case, we need to select the component's position at the same time. If you have a face selected, you can hold down the Control key and navigate to all the selectable points. If you have the inside bore of a cylinder like this, you can hold down the Control key and navigate to the midpoint or any of the endpoints associated with it. Now in our case, what we want is the center point of this outside edge as we're looking at it, or if we rotate it around, this inside edge. So this is going to be the first component as well as the first joint location. What Fusion wants to see is a secondary joint location where it can completely match up this. So we're going to select this location and it'll bring them together, and you can see that it's giving us a preview of the rotation direction. It's got the Z-axis as its rotation axis, and this is going to work out for us in this case. But notice that we also have some on-screen manipulators to where we can change that. We're going to say OK. And now we have a camera that can tilt up and down, and we have the red servo, which can rotate left and right. So now we have the 2 degrees of freedom that the camera originally came with. Let's go ahead and show the tilt mount. Now in reality, the tilt mount is a critical component because its pivot is holding the other side of the camera. Now there are a few things that we can do here. This is actually going to be a fixed or stationary component in relation to the servo, but we might want to make sure that the pivot points line up. So we're going to start by going to Assemble and Joint, and again we're going to follow that same selection process. We're going to move these together. We're going to allow them to rotate using the revolute type, and we're going to say OK. So once they're together, you can see that the whole location of the servo is pretty close. It's not perfect, but it's pretty close, and it's enough for us to say that it's possible that the resolution of the file is off. So we're going to go ahead and we're going to use it, and what we're going to do is we're going to create a rigid group. So we want to create a rigid group between 2 components. And under Assemble, we have the rigid group option. And also if you go into Joint, there is a rigid type. Now these differ in one specific way. If we go to Assemble and Rigid Group, we can select more than 2 components. If you go into Create a Joint that's rigid, it'll be only between 2 components. So in our case, we're going to select both of these, and we're going to make them rigid to each other. So this means they move around with each other. The camera can still pivot up and down because it has the 2 joints and those axes are in line. And we can revert back to that position at any point in time. We can turn on the cable guide, and because it's a body inside of this tilt servo component, it's going to move with it as well. So it's going to follow all of that geometry. Because the bodies cannot have individual joints applied to them, they'll be applied to the component at the top level. And you can see this by taking a look at the components and where the joints are located. So the tilt component has a subcomponent called tilt servo, and this tilt servo component will have joints applied to it. The pan, the sketches, and the joints folders are located at the top level of our document, and if we expand each of these components, then they'll have their individual bodies and origins associated with them. So if we expand this, you can see that we have Revolute 3, Revolute 4, Revolute 5, and Rigid Group 6. One thing that's handy is you can also see the angle on the screen. If we revert the position and we rotate this, we can see just how much each of these joints is being moved, and this helps us later on when we try to determine what our joint limits are going to be. For right now, let's revert the position, save the file, and we can move on to the next step.